Hello everyone, I am Amit Kumar, Assistant Professor in EKGEC, and I am in IT department. Today I am going to give a lecture on types of function and operation of functions. But before that, we have to know about what is the function. What is the use of function in our life? The use of function in our life is everywhere. If we are mapped with anyone, means if I am given an example that I am related to my father, I am related to my mother, because I am him or her child. So I am mapped with my father and mother. So this is makes a function. So in this world, everyone is mapped with anyone. So in the computer science and engineering department, or in the computer science and IT department, what we are going, how a computer science engineer is mapping all the documents or all the codes or all the functions which he has created in the code, they are mapped with each other or not. To help to create a function, this is the easy part for us, that to create a function, it is the easy part for us to help. We don't have to write up the code again and again. We can call the function and we can use it. But in the discrete function, we have to know what how the function is going to be used, and how the what different types of function is going to be used. Next, the topics should I will cover the types of function, composition of function, and inverse of function. These three topics are important in the discrete, covered in the function. Next, first topic is the type of the function. What are the types of the function? There are basically four types of the function. As there are the basically four types of the function: one to one, into function, many to one, and onto function. I am writing again. First, one to one, that is also known as injective function. Then many one, third into function, and fourth onto function. Many one, into function, and onto function. The onto function is also called the surjective. These terms are took as to understand about the shortcut forms, because if we are saying that it is an injective function, what is injective? One to one. What is surjective? On to. What is bijective? One on to. So these are the shortcut words which are going to be used in the function. But basically there are four types of function: one to one, many one, into, and onto. And again, if we are using the last, if we are using using these fours, then there are four again function: one to one into, one to one onto, one many one into, many one onto. There are basically eight types of functions. But in this, but now we will explain further slides what about this function is going to be happen. So first is injective function. What is injective function? It is one to one function, means a function in which elements of domain set is connected to elements of codomain set. What is domain and what is codomain? The element present in the set A is known as domain, and the element present in the set B is codomain. Like, as I am taking the f1 function, the function f1, here it is for set A and this is the set B. So the set A contains, the elements of set A contains the domain, and the elements contained in the set B is called codomain. And what is the range? How much domain is related, mapped with the codomain. So as I am taking, here are the domain values. I am writing the domain values for f1 domain. Domains are A B C D. Codomain 1 2 3 4 5 6. 1 2 3 4 5 and 6. Range 2 4 5 6. 2 4 5 and 5 and 6. These are the values of the domain, codomain, and the range. Now from this, as we have learned that what is domain, codomain, and range, so now we can explain the injective function. Now a function in which one of the element of domain set is mapped or connect with the one element of the codomain. like the example as I have told you, like in the function 2 it is clear visible that A is mapped with 1, B is mapped with 2 and C is, this is injective, means this is 1 to 1, one element of domain, is connected to one element of code domain. This is the best example for injective function. Next, what is onto function? As I have told you what is domain, what is codomain and what is range. So what is the onto function? A function in which every element of codomain set has one pre-image. Okay, one pre-image. As we are saying in this function that range is equals to codomain. Here we can say range of function is equals to codomain of function. Okay, this is domain, this is codomain. As you have seen in the example, all the codomains are codomains as I have values codomains ABC and the range ABC, means codomain is equals to range, then it is known as the onto function. Clear? As we have took the examples from a set A 1 2 3 4, set B ABC and the function is mapped with this one 1 to B, 2 to A, 3 to C and 4 to C. Okay, next bijective function 1 to 1 and onto. In the previous slide as we have learned about what is onto function, so now again we are learning what is bijective. 1 to 1 onto means it is both injective and surjective, is known as bijective, means it is 1 to 1, range is equals to codomain. What is the range of function Q? Range of function Q A, B and X. What is codomain of? Domain of A, B and X. So codomain is equals to range. So it is onto function, it's clear. Okay, what is into function? What is 1 1 function? It is mapped with one codomain is mapped with one domain. It is also mapped with, so this is example of bijective function. Into function. Into function means the function of the range is not equals to the codomain of the range. Codomain of the function is not equals to the codomain of the function. It means a function in which there must be an element of codomain that not have a pre-image in domain. Okay, that not have been, means we, if we are checking a codomain क्या होगा इसका 1 2 3 4 and what is the range 1 2 3 1 2 and 3. Okay, these are the codomain and domain, codomain and range, and what is the domain ABC. So the range is not equals to codomain, that is known as into function. Okay, next 1 1 into function means 1 1 okay into codomain is not equals to range. It's showing that codomain 1 2 3 4 and range 1 3 4. So codomain is not equals to range. So this is 1 1 into function as we have took. Many one function, yes, this is important. Some of the students are saying that, sir, as we are, what is the definition of function? How we can know that it is a many one, it is a function or not? So when the every element of the domain is mapped with codomain, it is not necessary that every element of codomain is mapped with domain. No, but every element of domain is mapped with codomain. It is necessary to be a function. So many one function is saying that the function f is said to be many one function if there exist two or more two different element in X. X means domain having the same image in Y, and Y is codomain. Okay, you can see this one as I have took the example, the X, the domain 1 2 3 4 5 and the codomain XYZ. Okay, and the function is mapped with X to Y such that function is saying that 1 is mapped with X, 2 is mapped with X, 3 is mapped with x, 4 is mapped with y, and 5 is mapped with z. We have drawn the diagram. If we have made the diagram and we are checking that every element of domain is mapped with codomain, and the codomain, in the codomain, if you are seeing that x is mapped with 1, 2, 3 also, but one has the image of x, 2 has the image unique x, means for the element x has the image, x is the image of 1 to 3 also. It is saying, and if we have made the diagram we can know that one. But how, if we can say how one is mapped with who is mapped with 1 x, who is mapped with 2 x, who is mapped with 3 x. So if the domain is mapped with any one function multiple times, this is known as many one function. Next, up to here we have know about what is function, what is the use of function in computer science, how is function is going to be used, and what are the types of the function, how the function is going to be used in the discrete. Okay, now the next important topic is composition of a function. Composition of a function means, as I am saying you an example, that if I am related to my mother and my mother is related to my father, who am I of that person? I am the son of both. I am mapped with that one. Means if a person is mapped with one person and that person is also mapped with another person, obviously A person is related to C person. This is an I can say, as you have learned in the transitive property of the relation, that if A is related to B and B is related to C, then A is related to C. Here also the composition function is saying that the function f, function A to B and function G, B to C, then the composition of function A to C defined at GOF of x, means it is a represented using GOF. Means if A is related, if if the function is going from A to B and the function B and the function G is going B to C, then A is related to C. And how we are representing in the discrete? GOF of x. Means if, as I have told you an example, if I am related to my mother and my mother is related to my father, then what is the relation between me and my father? That is simple thing. Okay, now I am taking the example. Consider a function f, 1 is mapped with A, 2 is mapped with A, 3 is mapped with A. The function f, only the function f, I am not saying the function g. 1 is, means I have given first is domain. I have put the values in the domain part, and the codomain part A and B, and the mapping I have done. Same as the function g has given, so the diagram has g has been created. So f is mapped, the function f, this is the function f, where x is mapped with y. Here x is mapped with y, and here the function g, x is mapped with again y. Again, no? So if we merge these functions A and B, then we can say that 1 is related to 5, 2 is related to 5. We can say that. This is the example. As we have took the function f and function g, so g of f1 is 5, g of f of 2 is 5, g of f is of 3 is 7. Because 3 is related to B and B is related to 7, the house 3 is related to 7, GOF of 3 of related to 7. So we have written these values. These are the important topics of the student which they can't get in a real, that how GOF, FOG is related. These are the compositions of the functions where we have to use. And what is the use of that functions? If we are coding if you are coding a part of if you are coding, then a function is a part. If a function A is related to B and function B is related to C, then automatically function A is related to C. This is the use of composition, is the use of coding. Now, as we are taking an example, consider A is equals to B is equals to C is equals to R. Let function A is mapped with A to B and function G is mapped with B to C. Has defined as function x is equals to x plus 9 and gy is equals to y square plus 3. Find the composition. As we have to find the composition of, means what is saying that function f is mapped with A to B and function g is mapped with B to C. Okay, it's given, and fx is defined as x plus 9 and gy is defined as y square plus 3. Now we have to find f o g of b. This we have to find f of gb. Okay, then gy, g of y. Then I can take that one b as a y. So b square plus 3, and f of x, what is x plus 9? Matlab b square plus 3 plus 9, it means b square plus 12. This is the solution. Now next question, as we are solving, GOF of b means G of FB. G of FB means f of b, means what is the function f? B, p plus 9. Okay, now what is the function? Y square plus 3, b plus 9 square plus 3, b square plus 18b plus 3 means b square plus 18b plus 84. This is the solution. Okay, I have cleared all the topic of composition. What is the use of function? What are the types of the function? Now next theorem in the composition is saying that let function f is saying that it is mapped with A to B and function g is mapped with B to C, and f and g are injective, then show that g o f are injective. Okay, so for the proofing, what is injective function? 1 function. Okay, and the statements has given f is injective and g is injective. If f is injective, g is injective, then how g of f is injective? If we have to show, means if there is a diagram A, B, C, this is the function f and this is the function g. If f is injective, then g is injective, then why not g of f is injective? For injective, we have to show that every domain have the mapped with codomain indivisibly, one of the element. So we have to let A1 and A2 belongs to A1 and A2 belongs to A. Okay, and by the definition of composition, we have wrote that if it both are equal, means if A1 and A2 is mapped with B, and if it would be the injective function, then A1 and A should be the equal. So here is given, since we have to find g of A is equals to g of f of A2. So we have to write this way. Now since question has given g as injective, so we have to remove the g. Now A1 is equals to A2 because f is injective. In the question it is given be the function f and g are injectives. That's when I have put it here. Therefore g of f is injective. Now the next topic is inverse of a function. How we are saying that what is the inverse of a function? This is the inverse of a function. Okay, if a function if a function f is mapped A to B and a function g b to A, then how it can be going to be saying that what is the inverse of the function? So this is the inverse of the function. If a function A and B, this is the function f, then this is the f inverse. Okay, this is the main concept. Thank you for this session. In the next session, I will teach you the Boolean algebra. Thank you so much.